So lesson 10.5 is about parabolas. That we're going to learn to write the standard equation of a parabola and its axis of symmetry, and then learn to graph them. And here you see in this picture an example of a parabola that's being used. And I'm sure if you watch much football, you've probably seen those things at football games on the sidelines where they use them. There's microphones in there and they actually pick up the sounds. It's pretty cool the way it works. So a parabola is a set of all points in a plane that are equal distance from a fixed point called the focus. Again, there we go. Distance from focus. All right, we talked about that with ellipses and hyperbolas. And a fixed line called the directrix. A parabola has an axis of symmetry, which is perpendicular to its directrix, and it passes through the vertex, and it passes through the focus. The vertex of a parabola is the midpoint of the segment connecting the focus and the directrix. So we all know what parabolas look like, right? We've done a lot of that over the last couple years. The focus is always on the inside of the parabola, okay, just like it was on the ellipse, just like it was on the inside of the graph, okay, for the hyperbolas. The directrix is a line that is on the outside of the parabola, and the directrix and the focus are the same distance to the vertex. Remember, the vertex is the turning point. And we talk about turning point instead of max and min because when we open it left and right, which we're going to do also, that you have to think of it as the turning point where it changes directions. Okay. So we have the directrix here, this line, which is outside the parabola, the focus on the inside of the parabola. And then the vertex is right in the middle between the focus and the directrix. And so here we have the standard form for a parabola with a vertex at the point HK. So we're using H and K again. And a reminder that when we talked about parabolas before, that with a parabola only one term is squared. If it opens horizontally, then y is squared, and it looks like the equation looks like this. If it opens vertically, which is what you've always seen in the past, then x is what is squared. So if it says x equals, it's horizontal. If it says y equals, it's vertical. Now, how do I know whether it opens left or right, up or down? Well, we know up or down, right? Okay. If the coefficient here, 1 over 4p, if that is positive, it smiles, right? Okay. If that's negative, it frowns. And with the horizontal one, if it's positive, it opens to the right, and if it's negative, it opens to the left. And they use the value of p to determine that, okay? So, because p is our variable in those situations. So if p is positive, it opens up or to the right. If p is negative, it opens down or to the left. Oops. The focus is always a change in the value of p. So if it opens horizontally, then if I do h plus p, and then the value of k, that would be my focus. If it opens vertically, then we'll do k plus p. Find it. The directrix, if it opens horizontally, the directrix is a vertical line. Okay? Because if it opens horizontally, then it's a vertical line. You can see what the graph is down here. Okay? So that means it's an x equals line. X equals h minus p. So notice, to get to the focus, they add p. To get to the directrix, they subtract p. So if p is negative, okay, that means they go the opposite ways. Okay. The directrix for one that opens vertically is always going to be y equals, and that's y equals k minus p. So we always need to know the vertex and the values of in the value of p to be able to graph and to be able to find the directrix and the focus. So we're going to use, here it says using the distance formula to write the equation of a parabola, but we're not going to use the distance formula. Okay, we're just going to go ahead and use the fact to find this stuff right here. So it says find the equation of the parabola with a focus at the point 2, 4 and a directrix at y equals -4. So I'm going to actually make a sketch of this graph first of all. All right, it says the focus is at the point 2, 4. So the point 2, 4 would be about here. And it says the directrix is at the line y equals -4. All right, and the directrix is just like the asymptotes. It's a dotted line. There we go. Okay. So if this is at the line y equals -4, right, then where's the vertex at? And the vertex is halfway between the focus and the directrix. So where would the vertex be at then? Where? At -1? At 0. Okay. Well, let's see. If we draw a segment, if we make a segment between a vertical segment between the vertex or the focus and the directrix, okay, it's got to be halfway in between. So the distance here is 8, right? From 4 to -4 is 8. And what's half of 8? 4. So if I go down 4 from the focus, then I'm going to be at the vertex would be at the point 2, 0. So the vertex here is the point 2, 0. That's halfway between them. So that means that h is 2, k is 0. Now I need to know which way it opens. And the way it opens is really, it's very simple. Okay? When it opens up, it never goes through the directrix. Okay? So could it open down? No. Okay? Could it open to the right? Could it open to the right? Because if it opened to the right, that means then the graph would go this way. And will that graph ever cross the directrix? Yes, it will, right? Eventually it's going to go through that line, okay? And if it opened to the left, eventually it would go through the line. So what's the only other option? Up, okay? So this graph has got to open up. Got to look like this. It's got to open up. And the easier way to think about that is, okay, where's the focus at? The focus is here. The directrix is down here. So the graph has got to go, the focus has to be inside the graph. So if it's a horizontal directrix, it either opens up or down. If it's a vertical directrix, then it opens left or right. So this is a smiley face, which means it opens up vertical. So that means we're going to be using there it is. Okay, so we're going to use, oh, hello. I don't know what I just did. That's interesting. Okay. So it opens vertically. I guess I just took a picture of the whole thing, didn't I? Let's see. There we go. What's that? Yep, I'm good here. All right. Okay. I don't know where that one went, so let's do another one. All right. So my equation is going to look like this. And we know that h is 2 and k is 0, so we have y equals, and we're going to have h minus 2, that quantity squared. What we don't know is the value of p. All right? And p is half the distance from the focus to the directrix. Okay? Half the distance. How far is it from the focus to the directrix? 8. Okay? If the graph opens up or to the right, p is positive. If it opens down or to the left, p is negative. So in this case, the value of p is positive 4. Half the distance from the focus to the directrix, or you could think of it as the distance from the vertex to the focus, or the vertex to the directrix. So then I put in 4 for p. So the equation here is going to be y equals 1 over 16 times the quantity x minus 2 squared. And make sure that you put the x minus 2, that quantity squared, either in the middle of your fraction bar or up above. Okay, so it's in the numerator. Okay, now we're going to take a graph, and from the graph we're going to find the equation for the parabola. Okay, so once again, we need to find the vertex, because we need to know h and k, and we need to know p. So vertex and p. So where is the vertex for this graph? Where does it change directions? Okay, at the origin, 0, 0. All right. Now, which way is it opening? Down, which, since it opens down, that tells me that the value of p is going to be negative. Okay. If it opens down or left, p is negative. All right. Now, we said p is half the distance from the focus to the directrix, or it's the distance from the vertex to the focus, or vertex to the directrix. So then what would that value be in this case then? Okay, negative 5. All right. Okay, it's negative because it opens down. So we're going to use the same equation we were looking at, y minus k equals 1 over 4p times x minus h, that quantity squared, because it opens vertically. So then I just plug in h, k, and p. So h and k are both 0. P is negative 5, and 4 times 5 is 20. So y equals negative 1 over 20 x squared. All right, the value of h and k were both 0. So we've got 0 here, 0 here, and p is negative 5, which means that 4 times negative 5 is negative 20. And always put the negative in the middle of the fraction bar or in the numerator. It does not go in the denominator. Okay? So make sure you don't put it in the denominator. Okay, let's do another one. All right, this one they're giving us the vertex and the directrix in this case. So let's make a rough sketch again. What this looks like. So we have the origin is our vertex. And the directrix is at x equals -6. Is that a horizontal or vertical line? Okay. X equals is a vertical line, so that vertical line is over here at -6. So which way is this graph going to open then? Well, if it opens to the left, that means it's going to go through the directrix, right? Okay, so that means it's got to open the other direction. So this graph is going to open to the right, which tells me the value of P is going to be what? Positive. Okay. So the vertex is 0, 0, and then the value of P is equal to a +6 because the distance from the directrix to the vertex is 6 units. And since it opens to the right, it's positive. So in this case, we're going to use x minus h equals 1 over 4p times y minus k squared. So we get x equals, and p is 6, so 4 times 6 is 24. And, oops. So x equals 1 over 24 y squared. Now I'm going to show you how to graph this, okay, before we move on, what the actual graph looks like. And so now, normally when we graph things, what do we graph? Y equals, don't we? Well, what's the difference between this graph and a graph that's y equals? Okay, directions, but what? They're switched. X and y are switched. So what is that? What do we call that when we switch x and y? Inverse. Okay, so this is just the inverse of y equals 1 over 24x squared, isn't it? So did we learn how to graph inverses? I think we did. Okay, I don't know if you remember it or not, but we did. So go to your y equals, and I'm going to make this bigger, right? And put in as if it was a y equals. So we're going to put in y equals, what was it? 1 over 24 x squared. So y equals, and you could use your fraction if you want here. Oops. 1 over 24, or just 1 divided by 24, and then x squared. And this, any calculator will do this. All right. So let's hit zoom 6 and graph it and see what we get. Okay. All right. There's the graph of the inverse of what we're looking for, right? Okay. So go to second program. Down to number 8. Okay. We did this before, right? Okay, didn't we? I know I've showed it to somebody before. So number 8. And then you can put in y1 there. Where do I find y1 at? Okay, it vars, y vars, and function. Okay. Or with the 84, you can just do alpha and trace. Okay, and it's there. Okay, vars, y vars, and then function, or alpha and trace. And then now, I don't want 2 of them. Now just hit enter, and there's the inverse. Okay. Now let's say I want to graph that on a paper. Okay. So if I go to my table, oops, go to my table, 0, right? And at the table, we can always do what? Just switch the values, right? I could graph the point 0, 0, obviously. Then I could graph the point 1.5 and 6. That could be one of my points. And then I could graph the point 1.5 and -6. Remember, we just switched the x and y's. Okay. And so those would be our 3 points. Okay. 1.5, -6. 0, 0, and 1.56. I could put those 3 points on my graph and then draw my parabola, okay, because we only need 3 points. Right, and we'll look at that more when we go to graph. Right? So I want you to then, okay, so they want us to graph parabolas. So they give us a equation for the parabola. They want us to find the vertex, the value of p, the axis of symmetry, which is the line that cuts the graph in half, the focus, and the directrix, and then graph it. So this is kind of like the hyperbolas, where there's a lot of information you have to find, and so you have to take your time with it. So finding the vertex and the value of p, we can work from there for everything else. So this is a y equals equation, which means it's going to open which way? Up, because it's positive 1/8, right? Okay, y equals in positive 1/8, so it's going to open up. So let's go back here for a second. And so we need all of this information here, okay, where it opens vertically. So let's copy this, see if I can get it over there. Okay, so here's our information we're going to need. All right, so we've got the vertex is what? Kaylee, what's the vertex? Okay, all right. So according to this here, what's the value of h? Or 2, yep, and the value of k is? Or -3, right? Right. Okay, so always the opposite there. So the vertex is 2, -3. The value of p, all right? Now sometimes this is really tricky, all right? This is not one of those cases, right? But sometimes it is. So when you're trying to find the value of p, it's always a good idea to take the coefficient of your x squared, which is 1/8, and that's got to equal 1/4p. It's not a bad idea to set that equation up, because sometimes it's not so easy as just 1/8. Okay, well, in this case, what's p? 2, okay? 4 times 2 is 8, so it's pretty easy. But sometimes this fraction here, 1/8, well, what if it was the number 4? Okay, then it's not so obvious what p is then. And so you're going to need to set up an equation and solve it, right? In this case, we don't need to. We can figure it out. So in this case, p is equal to 2. So does it open up or down? Opens up, right? Okay. So we got the vertex is at 2, -3. So, 2, -3, all right? And let's see, the value of p is 2. So since it opens up, right? To get the focus then, here's the focus. Let's see, this is focus, and this is directrix here. So to get the focus, then, we're going to do h, which is 2, and then take -3 and add p to it. So what do I get when I do -3 plus 2? Okay, -1. So we're going from -3, we're going to go up 2, and there's the focus right there. And then to get to the directrix, we're going to go down 2. So we go one direction to get to the vertex, we go the other direction to get to the focus. So So then you get the directrix we're going to go down to. So is it going to be a horizontal or vertical line? Okay, it's horizontal. It's going to be y equals. And if I go down to, we're at y equals -5. And make sure you don't just put -5 there. It's actually a line. So we've got the vertex, the value of P, the focus, the directrix. We need to do the axis of symmetry. And forgot that. Okay, so axis of symmetry. Okay. Well, I'm going to do a rough sketch here. This isn't the actual graph. All right, we'll graph that. Okay. The axis of symmetry cuts the graph in half. Okay. So would it be a horizontal line or a vertical line that cuts it in half here? Vertical. So that vertical line is going to be right here. And what do we call that vertical line? X equals what? Okay. X equals what? Okay. X equals 2. All right. And look, it's right here. There's the axis of symmetry is just X equals H. If it opens vertically, axis of symmetry is X equals H. If it opens horizontally, axis of symmetry is Y equals K. Okay. X equals 2. And then the last thing they want us to do is to graph it. Okay, so now, for graphing it, take out your calculator. Oops. Let's do this. Let's use our tools. Okay. I don't actually have to, but I'm going to, because all I need to know is if I know the y-intercept, if I knew what the y-intercept was, so the point on, if I knew the point on the y-axis, that means then there would be another point over here the same distance away, right? Because the graph is symmetrical. Right? So go ahead and put it in your y equals. Now, how am I going to put that in my y equals? What do I need to do first? Okay. Yep, we need to minus the 3. So in our y equals, we get 1/8. So I could do 1 divided by 8, put in parentheses, Ashley. Okay. And then x minus 2 in parentheses, that quantity squared, and then minus 3. And then graph it. Oops, I changed my window. Zoom 6. There we go. So now, to graph this, I only need 2 more points. I need a point on the left side of the axis of symmetry and a point on the right of the axis of symmetry. And so in this case, the y-intercept's probably not a good value because it's really close to it. But can we approximate where the zeros are? Okay, just by looking at the graph. If I look at the graph here, it looks like there's a 0 at pretty close to 3, -3, right? And then there's one over here at 2, 4, 6, about 7. Okay, so I'm just gonna on my graph then, and I don't think I can move this because I got all this other stuff on there. Get rid of that line for a second. Okay. Yeah, there. Come on, move. There we go. Okay. So I can put a point here, right about -3, and here, right about 7. Okay, and then draw my graph. And there it is. Okay. And if you're doing it with if it was an x equals graph, okay, then just switch those points. Okay, what would be the zeros here would actually be since they're the x-intercepts in this graph, that means they'd be the y-intercepts if it opens horizontally, right? Because I'm just switching from x being 0 or from y being 0 to x being 0. All right, let's look at another one. I'm not. Yeah, let's go ahead and do 3A together, and then I'll have you do B. Where are we at here? Ooh, nice long one. We're at 30 minutes already. Okay. All right, so write it down. And I expect these graphs to be accurate. That's why you should have graph paper, so you should have exact graphs, or very, very close to them. Okay, so our vertex. Okay, the vertex is HK, right? H goes with X, okay? K goes with Y. A lot of people make that mistake on the quiz. Not as many as I thought, actually, but still quite a few. So 1, 3 is the vertex. The value of P in this case, all right? Not too bad, 1 over 12, we can figure that one out. For letter B, might be a little bit more difficult, but in this case, P is 3, because 4 times 3 is 12. Okay? 1 over 4P equals 1 over 12. So P would have to be 3. Okay? Next thing we want is the axis of symmetry. Okay? In this case, since it opens horizontally, that's going to be y equals the value of K, which would be 3. Y equals 3 is our axis of symmetry there. Move this graph down a little bit. Come on. Oh, I locked it, so it wouldn't move. All right, I'll write over here. Okay. All right, so we need to focus. Now, does this open to the left or to the right? Let's see, we got the vertexes at 1, 3. And so let's pull this down here. And P is 3. Did we say it opens left or right? If P is positive, that means it opens to the right. Okay, so our graph is going to go here. All right, it's going to look like this. Graph's going to look like this. It's going to come from here, go there, and go that way. So that's what our graph's going to look like. So that means the focus then is going to be to the right. So I have to take the value of X and add 3 to it because the value of P is 3. So the focus is going to be at the point 4, 3. All right, because since it opens to the right, the focus has got to be inside the graph. All right, the directrix then is going 3 the other way. So if I went 3 to the right, I got to go 3 to the left, and that puts me at -2. So that's going to be X equals -2. Because it's a vertical line. Since I'm opening horizontally, the directrix is a vertical line. So we've got our directrix would be here. Okay. All right, now, the graphing of this. You know, you could I could pick some values for X, stick them in there, get a point, and then plot the other one, right? Like I could put 6 in for X, see what my Y value is, plot the point, and then go up here and plot the same point. Right? So what we're going to do is we're going to put it in our calculator. So, but we're going to do what when we put in our calculator? We've got to switch the X and Y, so we're doing inverse. So we've got 1/12 x minus 3 squared, and then plus 1, right? We have to add 1 to both sides. So y equals 1/12 x minus 3, that quantity squared, plus 1. And then graph it. All right. Now, if so if we want to look at what it should look like when we're done, okay, if we go down the second draw, number 8, put y1 in there, okay, then this is what our graph should look like when we're done, okay? So we can do some estimating, we could from that, or we could go to our table, and let's see, we've got when x is 3, y is 1, which means then that when x is 1, y would be 3. So if I graph the point, which you won't let me until I get rid of this. So if I graph the point 1, that was a really good point, wasn't it? Since that's our vertex, that doesn't help me any. Let's try that again. All right, 0.13 doesn't help me. Come on, get back up here. All right, so what do we got here? We got the 0.6, 1.75, or here's a better one. We got the 0.94, okay? The 0.94 is going to be the 0.49, right? Okay. So, and I don't have 49 on here, but I can. Okay, so we have the 0.49, which means then I went from my focus, I went up 5, right? So from my focus, I can go down 5. 1, 2, 3, 4, 5. And I'd have the 0.4, -2. And I can draw my graph. Okay, you all right with that? Okay, that's the hardest part, is the actual getting the right graph on there. But if you go to your table, okay, find a couple points, you know, and you have to switch them, and you're all set.